Hello, this is Mr. Rasmussen with Algebra 2, Lesson 94. And we look at dependent and independent variables, functions, and functional notation in this lesson. First of all, starting out with dependent and independent variables, I have an equation here, y equals 2x plus 4. Let's say we're to just pick a value for x. If x equals, and they use 5 in the book here. If x equals 5, we plug it in. We get y equals 2 times 5 plus 4. So 10 plus 4, y would be equal to 14. In this situation, since we picked a value for x, which is 5, that would be independent variable because it's independent of everything else. We just selected that. Then the 14 is dependent upon what the x is. So y14 would be the dependent variable because it can only be what the equation lets it be once you put in the dependent variable. So just identifying that there. As we move on here in functions, when we have an input as x, we call that a domain, and then what we get out, or the result, y, is the range. Okay, so x being the independent variable, we put that in to the function machine, if you think of it, and it can only give us one answer out, which is dependent variable, which is usually our y value. I'll read what the says about a function here. It's a map between two sets of associates with each element of this first set a unique one and only one element of the second set. The first set is called the domain, like I said, and then the answer of this part is called the range. So a function is a set of ordered pairs in which no two pairs have the same first element and different second elements. So you can't have the same input give you two different answers. One input only gives you one answer, and two different inputs can give you the same result, but the same input can't give you two different results, one for one. And so that's what it's mentioning there. Okay, the domain must be specified or implied. Number 2, a way must be designated to find out what the answer is, and there must be exactly one answer for every one member of the domain. So once again, the domains are the inputs, and then the ranges are the outputs. So let's look at example 1 here. And in example 1, we have 4 and 3 as our two inputs, and then regardless which one we put in, they show that both the outputs both are 3, which is fine. If it's 4, ends up being 3 coming out. If it's 3 coming in, 3 coming out, that is a correct function. The second one here is not a function because even though 7 does give you one answer 3, 5 can't give you answer 3 and 4. It has to be one or the other. 5 can only give you one of those two answers. This is not a function. This third one here, 4 gives you 5, 6 gives you 7, but m doesn't give you any specification of an answer. It has to give you something, therefore that one's not a function. And then the last one here gives you an equation. The x is the input, and then the y is the output. So really, for any real number you put in for x, it's going to add 2 and then get your output. That one is a function because there's not going to be any contradictions there. Okay, looking at example 2, the format is a bit different, but remind you in these coordinate pairs, the first value is the x and the second value is the y. So basically we have to look through here, and if we have any of the same first number, x's, we have to check them to see if the second part is the same. So in the first one here, 4, 7, -3, -6, none of the x's are the same, therefore that one's going to be a function, no contradictions or conflicts. In this one here, 4, 5, 7, and 6, no contradictions there. That one's also going to be a function. In C here, we got 5, 4, 7, we got 5 in the x spot showing up twice. It says -2 as a result here of 4 here. That's a contradiction. C is not a function. Does not work. Now, if we were to replace this 4 with a -2, then it would be a function because there would be no contradiction because 5 gives you negative 2 just both times. All right, the last one here, 7, 3, 6, and 4. No contradictions there. That one's also a function. If you wanted to look up more on this particular thing of recognizing functions, go and watch the video for Algebra 1, Lesson 84, and I go through this in a little bit more detail in that lesson there. Same thing, just for Algebra 1. Okay, moving on here to our third part here is where they give you two equations, and we're simply selecting the correct one and then solving it. And once again, same thing as far as we have an x value, our domain, and we're putting it in and then solving for our range. Okay, so in this case here, we have an h equation and we have a p equation, and then it says find p of negative 3. So negative 3 is what we put in for the x value. This p tells us we're not going to use the h equation. We're going to use the one with the p in it. So we just disregard that first part. And then we're going to plug it in for our second part here. So negative 3 squared minus 3 times negative 3. Negative 3 squared is 9. And then negative 3 times negative 3 is plus 9. So it looks like our answer to that one there is p of negative 3 is equal to 18. Okay. Well, let's take a look at our practice problems. Encourage you to do them yourself and then check your work to just run yourself through some practice. Okay, the first part there is identify which one of these are functions. I didn't take the time to write it out, but you can look at it there in your book. All right, looking at practice A, we've got in the x spot, we got a 5, 4, a negative 3, and a negative 4. No conflicts, so yes, A is a correct function. All right, in B, we've got a 1, a 2, a negative 5, and a 3. B is a function, no conflicts there to look at. In C, we've got a 1, a negative 1, a 6, and a 4. Once again, for this one, I don't see any contradictions there. Nothing's the same, so that one is also a function. For D, we've got 3, 0, 3, and negative 2. We got 3 showing up 2 times. So the first 3 gives us an answer or a range of 2. The second 3 gives us 0. Those can't both be true, so D is not a function. All right, and then our last practice problem here. It says find p of negative 5. Well, they give me 2 equations there, one h of x and then p of x. I'm going to disregard the h of x because I don't need that one. I'm going to have the p of x is equal to x squared minus 5x, and I'll plug in my value. So negative 5 squared minus 5 times negative 5. So 25 minus, looks like negative 5 times negative 5 is plus 25. So it looks like p of negative 5 is equal to 50. And there's my answer. Okay, please feel free to text me if you need some direction there. Have a great day.